Hi and welcome to the channel. Firstly, let me start by thanking all of you who has been liking, sharing, watching all of the my previous videos continuously. By doing so, you have been always motivating me to bring such videos more and more. Uh, Let me appeal for all rest of you who has not subscribed to my channel yet. Kindly subscribe to the channel right now. Let's learn something interesting, something more useful, which is required in a day-to-day basis in the industry. The topic for day is AWS auto-scaling. It is very interesting and very useful. Suppose that you are running a website or an application which can serve up to 5,000 requests per second. Very initially, the traffic that your server used to get it was around 500 requests per second. After a week or so, the traffic start getting double because you started making more sales or the application started getting more popular, and as a result, the more traffic is expected, right?
Right? So,
And eventually, after a month or after a couple of weeks, you started realizing that the traffic that is coming, it's very closer to the server capacity that you have started with. That means the number of requests in the traffic that is coming, which is up to 5,000 or somewhere close to that. The moment when the number of requests crosses or surpasses the capacity that server can handle, then what happens? Boom, the server will crash. While designing the infrastructure, it is very, very important to keep the very long-term thinking into mind. Um, Probably in certain cases, you can do the guesswork or use the past experiences, or you can have some historical data which will help you to sustain for some time. Um, Many cases you will not have any kind of previous experience or stats or informations which will help you to design the infrastructure in a way that it can sustain for longer. Here comes our first keyword, scalability. Scalability is a quality or property which allows the server capacity to grow in line with the traffic. Suppose the traffic grows higher, the server capacities grows higher as well. When the traffic drops, the server capacity also drops in a same line so that it can tackle all of the traffic that is coming. So there is no guarantee which time during the day or night the traffic is going to be higher or lesser. So the server capacity, based on some kind of parameter, it detects those information, detects those traffic hikes, and then accordingly adjust the traffic capacity so that it can handle all of the increased or decreased traffics. Well, there are two ways you can think about the scalability. That means there are two types of scaling is possible: the vertical scaling and the horizontal scaling. In the case of vertical scaling, a single server is run all the time to handle entire traffic. The extra resources will be added whenever there is a traffic increase. The concept of hypervisors are used to resize the machines. The resources can be CPU, RAM, disk, or network bandwidth, etc. The action of adding additional resources to the server is called scale up. There is a counter action. When there is no need of running the same size of machine, you start resizing, downsizing the machine, and that counter action is called the scale down. Vertical scaling is a good fit for small or medium sized enterprises, but not preferable for the large enterprises. There are a couple of downsides of using the vertical scaling. When you are done with doing the resizing up till the highest possible capacity of the machine, what happens after that is to replace the current machine with the larger size machine. Otherwise, you cannot do the further scaling, and that is very worst because that will cause the downtime in the system availability. No customer today likes to have the downtime for a single minute or hour, right? Horizontal scaling speaks about adding more nodes or machine to the system so that the traffic can be redistributed among all available nodes in a way that not a single individual node or machine is under stress at any given point in time. So adding the more nodes to the system is called a scale out. Giving up or reducing the number of nodes which is not required is called a scale in. So you either scale out or scale in into the horizontal scaling. Well, as we have a very good understanding of how scaling works, let's talk about the AWS auto scaling. AWS offers auto scaling as a service to handle the scale out and scale in requirements automatically. This happens based on certain data pointers, the metrics, which can be pre-configured to detect the sense of traffic increase or decrease, and then according to that scale out or scale in. Auto scaling uses the CloudWatch internally to read the parameters and then trigger the scale out or scale in actions accordingly. AWS Auto-scaling makes use of CloudWatch provided metrics as a scaling metrics to take a call when to trigger the scale out, when to trigger the scale in. You can select one of the scaling metric from the given list here to trigger your scaling requirements. For example, if you have configured average CPU utilization as a scaling metric, then auto scaling group is going to take an average of all the running node CPU utilization percentage and compare with what value is configured as a threshold. If the value is lesser than the threshold that you have configured, there is no action is going to happen. If there is a value increased or value above the threshold configured, then there is a scale out will be happening. Auto scaling service is completely free. It doesn't have any cost behind it. But when auto scaling happens, there will be the provisioning of resources behind the scene, and those resources are something that you have to pay for. At the moment, auto scaling is supported by only four services, which is mentioned here: EC2, ECS, DynamoDB, Amazon Aurora for read replicas. So these are the four services. We'll be seeing the demo on EC2. AWS Auto Scaling also supports something called predictive scaling. This concept is latest addition into auto scaling basically. This is introduced to make the scaling perform better and better and more efficient, make you prepare beforehand the traffic arrives based on the certain historical data. The machine learning is used to form the daily and weekly charts or patterns. Based on that, the analytically it judge the how it is going to be the traffic in the next 48 hours. So it requires at least the data of the 24-hour previous data of the 24 hours to make certain anticipation about the traffic and suggest you the scaling improvements, and it can trigger the scale based on that. Thanks for sticking around and listening to all lectures. Let's see the quick demo how the AWS auto scaling works. For the demo, I'm using AWS Management Console, but same can be achieved using the CLI or CloudFormation. So I'm assuming that you have already logged into AWS Management Console to follow the steps if you're in case following the steps. Once logged in, then click on the services to locate the EC2 service, or if it's in a recent service list, if you have used it, then you can click directly over here. Otherwise, from the services, should be in the compute first service. Click on the EC2. The EC2 dashboard loads. Uh, Scroll all the way down and look for auto scaling, and under the auto scaling in the left navigation pane you can see the launch configuration and auto scaling groups. So there are two things which you should know about: the launch configuration and the launch template under the instances. Both does similar job. So latest one is the launch templates, and this gives a bit more advantage over the launch configuration. And recommendations from the AWS is used to use the launch templates over the launch configuration. So you should follow the launch template for this demo. I'll be following the same. Uh, Click on the auto scaling groups first, and we are starting from the very scratch, so we don't have anything else yet. We'll be creating everything on the go. So once you see this screen, you can click on the create an auto scaling group. So auto scaling group is a logical group of similar servers. For example, if you have DB servers or application servers, the auto scaling group can be of all the servers of application server into the same group. Give a name to your auto scaling group. I'll just type my auto scaling group. And so far we have not created any launch template. So this is mandatory because the auto scaling group is going to use this template all the time to launch a new instance wherever there is a scale out requested. So click on the create launch template, go over there, let the window load. Give a name to this launch template. I'll just give a name as a my launch template. I'm just going to follow the same naming convention. Make sure you are following the naming as per your requirement. Some descriptive name. The rest of the thing we can just skip through. Template tags are the tags which require to be given to the template that you are creating. So later part, if you want to refer a query, you can use those tags from the different services like CLI or Cloud Formations. It's very helpful. Source template, if you have any existing source template, you can copy from there for this template and make this template. As of now, there is no scope or the requirement as such for this demo. So we'll just skip all these details. Click on the AMI and choose the option, the first one, the Amazon Linux 2, which is for our demo purpose. So we don't care much. And here the instance type I am going to select as a T2 micro as per the eligibility of the free tier. So I'll select the T2 micro. You can feel free to choose as per your requirement. Key value pair, I'm not going to connect post launch, so I'll just skip this part as well. Rest of the thing you can just scroll down and click on the create launch template. Rest of the things are not mandatory. We'll just skip it. You will see the launch template is created. You can click over here to just verify that all the details are there. And once done, you can click on the close and come back to the auto scale group. So once you come back to the auto scaling group wizard, refresh this and should see the my launch template that the name I have given. So that's the template that recently got created. Once you select it, you can find it out the details that you have given in the launch template. So you can select the subnet group if you want, or you can just leave it everything as it is and move to the next screen. I'm just going to have a couple of subnets selected. By doing this, this will make sure that these are the subnets where the availability zones are going to participate into the scaling process. Uh, Click on a next. This is important. The ELB, the load balancer, basically is needed whenever you scale out. Definitely, the load balancer would like to know about which are the new nodes which are available to uh, distribute the traffic to. And load balancer depends on auto scaling group to give the details based on the health checks and various other information like targets and stuff like that. So you can put that information and health check, like how frequently the health check should happen, what should be the grace period of it. So those information, if you want to configure, you can configure over here. But since we are not having the ELB in the scope of this demo, we'll skip for now. In the next video, we'll see the ELB along with the auto scaling group. Over here, you can start with defining the minimum capacity. So this is the capacity. You do not want to go beyond this number. So it can be any number. So you can keep your regular traffic load, how much the regular traffic load is expected to run on. Suppose if you have um, uh, regular traffic which can be served by 5 different servers, you can configure the minimum capacity as a 5. We'll come back to the desired capacity, don't worry about it. And then suppose if you want to scale on the demand wherever there is a lot of traffic coming and you want to keep growing the number of servers to tackle them. Of course, you will regard the cost factor here. So suppose if you want to go up to 20 of the servers to uh, support all the traffic which can be taken by up to 20 servers, you want to handle it, and beyond 20 you don't want to care about it, or you think that it's not possible, the traffic will reach to that level, or you don't want to consider that because already the business requirements are already fulfilled, and most of the customer use cases scenarios are covered within this. So in that case, this will be your limit. So we'll have always the minimum required servers. The number of servers that is going to run is 5, and maximum it would be 20. So this is what the definition of the boundary you have put it. So desired capacity should fit within the minimum capacity and maximum capacity. So it should be the value equals or more than minimum capacity, but lower than the maximum capacity always. Desired capacity is something that you want to understand as a initial capacity as a value. So that means when this auto scaling group launches, it will launch that many number of servers, and this value is going to keep on growing based on the factors that you are going to use. For example, the scaling metrics that you are going to choose, based on that the desired capacity will be always keep on growing. So you can understand this is the initial capacity plus actual number of servers running in the current time. So I'm going to just keep it as a 2, and I'll keep the minimum value as lowest possible. So I'll put it as a 1, and then I'm just going to adjust the value quickly to set it up to say up to 5 server or 10 servers. So 5 servers, and this is what I'm configuring for my application server load. Suppose this is the server definition for the application server. Then I'll leave all the details as it is and then move to the next screen. You can escape this part as well. If you want to configure any notification services, suppose if there is a health check, and if there is a health check, in the health check, you find that one of the configured scaling metric that you have configured, that is triggered, and there is a scale out process happening. So this kind of information, if you want to get notified, you can you can subscribe here in the SNS simple notification service, create a topic, and then dump all the such messages there. It also notifies when there is a shrinking in server size, server capacity happens. That means if the auto scaling group auto scaling is going to take a call to terminate any resources, it will also notify there. So right now we'll skip it, but it's always the real time that you will be not skipping it. We'll leave all of them as it is and then move to the create auto scaling group, and this is my auto scaling group. Okay, This is something that I've not configured my scaling metric uh, as of now. So let's go and change the scaling metrics. So
So
you
you
say
say
add
add
policy,
policy
and
and
then
then
you
you
say
say
what
what
type
type
of
of
policy you
policy you
want
want
to
to
add.
add.
So
So
I
I
want
want
to
to
just
just
go
go
with
with
a
a
target
target
policy,
policy,
keep
keep
the
the
name
name
as a
as a
target
target
tracking
tracking
policy.
policy.
We are
We are
not
not
going to
going to
modify
modify
anything
anything
as
as
of
of
now,
now.
and
And
choose
choose
the
the
average
average
CPU
CPU
utilization.
utilization.
What
What
all
all
other
other
factors
factors
are
are
supported
supported
here
here
is
is
network in size bytes and outsize bytes. That means what are the size of data that is coming, and what is the size of that's the request size and response size basically. So if you want to measure that size, and based on that you want to trigger a scale out or a scale in. Or the load balancer per target is nothing but your node, which is taking the number of packets, number of requests basically. So request packets sent to the particular target, that is taken into account by the load balancers, and based on that it can trigger. So these are the four factors which you can configure your scaling policy on, right? So I'm just going to go with the average CPU utilization, and here there are something called performance versus cost or balanced, right? So there are three different things. So if you put the value lower, that means you are choosing the performance. So this is in percentage basically. So if you put something like 40%, this is safest for the node to take a load.
load.
So
So
the
the
server,
server,
the
the
node
node
is
is
running never running more than 40% of the load on the CPU side, and this is going to give a better performance, but the CPU utilization is still under, so you may require a more number of such servers to handle the increased traffic, and that is something going to be a bit costlier. If I put it as a 50, this is more like you can say as a balanced one, right? So this is trade-off basically. So the more the number you have, lesser the cost, but performance may suffer. So you can choose between the performance and cost. So if you want the performance, then you can lower the number of the CPU utilization percentage always. This is like basically the time is the default is 300 seconds. So whenever there is a metric trigger, how much time you want to take to warm up and uh, launch the servers, right? So this is like a when the provisioning of the server should trigger if the metric is already identified from the CloudWatch. So we can just go leave it blank. This is like a default 5 minutes, and move on, and we did the job. So now if we see that we have added 50%, which is like a general, you can say the balanced one, the cost balanced, performance and cost balanced, and we have the all the actions performed so far and done. Click on the instances to verify that there are two instances must be launched by now. So these are the two instances which are launched. So remember, we put the desired number of instances as a two. So that's the initial capacity that we planned by the auto scaling group. So when you configured in the auto scaling group as a policy, two servers, two instances of the same server should be running. So this is what it has been provisioned by auto scaling group. Suppose if I terminate
terminate
any of them or both of them, what will happen? So if I terminate here, so that is what we gave as a requirement. If in a normal situation, all the times we should be running with the initial capacity that we have given. And when we start scaling down, scaling in, I mean, then we should not be able to breach the size of the minimum capacity, which is one. So we can, at any time, we can keep terminating and keep terminating the resources, but we'll not be able to terminate all of them The minimum capacity will protect the minimum number of server should be running all the time. So if we refresh now, there should be some warm-up period. So let's by the time it comes back, let's terminate the other one as well. And then now we should see server is shutting down. Should we terminate? It shows to terminate, I guess. So should terminate, and then same time we should see the two of the servers should come in couple of seconds or minutes, because we have some kind of warm up that we have given. So it will take time to come back, but we'll keep on refreshing. So both of them are fully terminated now, and our auto scaling group, we could have put the seconds as a lower because we put 300 seconds, which is causing the 5 minutes of delay into this. So one of the quick learning is that we should have the correct measure or correct input for the warm up, right? So let's wait, and now this is triggered that happened. Now you can see the one server launched, and if you see the subnets that I have mentioned, right? So I have given a 5 different subnets, starting from, I guess, all of them I have selected except for the one. North Virginia has 6 subnets, six different availability zones. So default VPC had a six subnet, and all these availability zones were having individually configured inside the subnets. So this strategy is basically automatically being used by the AWS to choose the subnets randomly and put the servers in a different one. You cannot see the servers are into the same availability zone. So that is also one of the benefit of using the auto scaling group. It will not launch all of your servers into the same availability zone, and that way it also protects your infrastructures from the failures. Suppose all the servers are launched into the same availability zone, that's going to cause a problem if that availability zone are under the problem or under breakdown, right? So that's the good strategy here. And if I refresh, I should see another triggering by sooner. So let's keep on refreshing. It will take a little bit of time to come back, so but it will come back for sure. And here you go. The second server launches. So the warm-up period is making the magic basically. So you should adjust your warm-up period based on what can be the waiting period. So not to miss any of the traffic. If you want to, because we configured the CPU utilization percentage as a 50%, so probably our traffic is still going to be entertained by the CPU because still the CPUs are good enough to take the next couple of minutes load, and that way we are safe. So this is how it is happening. So if we keep terminating, it is going to keep launching. So this is something you can always play with and find it out how the auto scaling group works. So next thing should be the elastic load balancer to see that how auto scaling group can be leveraged to do all the traffic distribution dynamically, launching the new servers in the same auto scaling group. For example, the application server or DB server or web site or any such things, right? And see that how those are replicating dynamically by the auto scaling group, and they are maintained always in a number that is desired, right? So that is how this whole thing is going to work. So with that, I'll say bye bye and thank you for watching my videos, liking them, and I'll meet you in the next one. Thank you.